Question number 2. This is my xy plane, and here is my mirror, which is x equals to y. Here is my t-table. This is my x, and here is my y. If the given graph or the original graph is a fine parabola, it is y equals to x squared. These are the coordinate points of the parabola. So for the inverse of this function, all the x values become the y values, and all the y values become the x values. The inverse graph of the function will be in this shape. Look what I'm doing here. I want to find the inverse function from the graph. Inverse function from the graph. So the graph has been given, which is a parabola. It is y equals to x squared parabola. Now the coordinate points of the parabola are these. These are the coordinate points of the parabola. Like here at origin, my x value is 0 and my y value is 0. At -2 here, at -2, -1, -2, at this point, my y value is +1. At -3 here, -1, -2, -3. At -3 here, my y value is +2, +2. Similarly, at +2, +1, +2 here, my y value is +1. And at +3 along x-axis, +1, +2, +3 along x-axis, my y value is +2, +1, +2. Now when it comes to the inverse of this function, for the inverse function, all the x values for the original function will be the y values. Like -3, -2, 0, 2, 3 are the x values for the original graph. They become the y values for the inverse graph. Similarly, all the y values for the original graph, which are 2, 1, 0, 1, 2, become the x values for the inverse graph. Look, as I said, this dotted line behaves as a mirror. It is x equals to y. So at x equals to y, I draw this dotted line, which is like a mirror. It must be at x equals to y. It is at x equals to y. When I place this original graph in front of this mirror, I will get this kind of shape inside the mirror. This kind of shape. Just take something like a wire or any rubber and make a parabolic shape. And when you make a parabolic shape, just place that parabolic shape in front of the mirror. Practically, do it practically. Inside the mirror, you will get that kind of shape, this kind of shape. This is the inverse graph of this parabola. But one thing has been left, which is very important. Do we really know that the inverse of this graph exists? How we know that? We're gonna try it. Just do a try here. Let me first try the vertical lines. Yes, it satisfies the vertical line test. This line touches it here, this one touches here, and this one touches here, the other one touches here. I'm talking about the original graph, not the inverse graph. So the original function satisfies the vertical line test. But as I said in the beginning, that the original function or the given function must pass the horizontal line test. Sometimes it may pass the vertical line test, but it does not pass the horizontal line test. So let me try the horizontal line test here. But when I test the horizontal line test, something happened very dangerous, because it does not satisfy the horizontal line test. All the horizontal line touches the given graph of a function twice, more than once. This line touches it here and only here. This line touches it here and here. It also touches here and here, which means that it has two inputs. It is not a one-to-one function. For the one-to-one function, the graph must pass the horizontal line test. Now, as I said, that ultimately this horizontal becomes the vertical lines for the inverse graph. Can you see that the inverse graph also does not satisfy the vertical line test? For the inverse function to be a function must satisfy the vertical line test. The inverse graph has been failed here because it does not satisfy the vertical line test. Touches it here and here. Similarly here and here. So all the lines touches the graph more than once, because my original function does not satisfy the horizontal line test. So these horizontal lines become vertical lines for the inverse graph ultimately, which is also failed for the inverse graph. So I can write that the inverse of this function does not exist. It does not exist. The inverse of this function does not exist. Because for the inverse function to be existed, the original function must pass the horizontal line test. This parabola does not pass the horizontal line test. Therefore, the inverse graph also does not satisfy the vertical lines. For the inverse graph, vertical line is must. It must pass the vertical line test. Then we can say that it is inverse function. Otherwise, it is not inverse function. So the inverse of the parabola does not exist. Inverse of this function does not exist. As I have explained in question number 1, that there are two things. One is the inverse relation and the other is the inverse function. From this graph, the inverse relation exists. As I said, inverse relation is nothing. It is just the inverse, the opposite graph of the given graph. Which means that whenever you put this graph in front of the mirror, you're gonna get this inverse graph. That relation that when you put something in front of the mirror, you're gonna get the exact shape inside the mirror in the inverse form. That phenomena, that property is called the inverse relation. Inverse function is a different thing. Inverse function is a proper function. For the inverse function to be a function, it must satisfy the vertical line test. Here, when it comes to the inverse graph, it fails the vertical line test because it is not a function. So I can write that the inverse of this function does not exist. From the inverse of this function, I mean the inverse function, which is failed here because it does not pass the vertical line test. From the inverse of this function, I don't mean the inverse relation. The inverse relation of this graph exists because I have this inverse graph for the given graph. So its inverse relation is already there, but its inverse function does not exist. Therefore, I can write that the inverse of this function does not exist.